Hi everyone. From this morning's virtual classroom lesson and discussion, we were looking at some recursive formulas, and I also got a couple of emails asking for help. So I'm just going to quickly go through this in video format and post it. This particular question set came in as an email, so just going to get my pen working here. Now, the individual asked for help regarding question number 2, A, B, C, and D, but I don't have any of the values for those because it's in reference to question 1. And as you can see here, I only have E and F for question 1, but question 1 was asking for the next terms, and then question 2 is asking for the formula, and this is where we're interested right now because we're looking at recursion formulas. So if we have a look at this sequence 1e, fairly easy to see that to get from 7 to 10, we have added 3. To get from 10 to 14, we have added 4. To get from 4 to 19, we have added 5. And even though this doesn't suit the definitions of an arithmetic or a geometric sequence, there's no common ratio or common difference, we at least can see the pattern. So I think it's fair to say that most of us would be able to say, okay, each time we're adding one more, right? So our next one will be plus 6. So 19 plus 6 will be 25. And then our next one where we added 6, this time we're going to add 7. And so we'll have 25 plus 7 will be 32. Okay? And that's fine for getting the values. But question 2 asks us to find a recursion formula. Okay? So to do this, remember a recursion formula always uses the previous term. You must know the previous term in order to find the next ones. And so what we know here, and I'm just going to do the solution down below here, we know that our first term was has a value of 7. I'm going to use A to represent the 7 or the value this time. So A1 was 7. And I know what I want to be looking for is my next terms. So if I'm looking for an, I need to be able to express that in reference or in terms of the previous term. And the previous term would always be n minus 1. So let's make sure that that is clear. Please pay attention to the, sometimes using the pen, the notations will disappear, especially if there's small lines. So sometimes if I do even a plus sign, for example, we'll lose one of the lines and it may appear as a minus. So just pay attention to that, and I obviously will try to catch it. If I think about the sequence I was given, so 7, 10, 14, and 19, those were the first 4 terms. If I know A1, okay, let's pretend for a minute we don't have all of the terms, but we want to figure out A2, okay? Then I want to figure out A2 in reference to the previous term. So that means n is 2, 2 minus 1, right? See there, I lost something there. 2 minus 1 will be A1, and we'll be able to go for our value of 7. So, sorry, this is worse than normal now that I've mentioned it. All right, but we know it's not just that. What's the relationship? Well, we know we're going to add a value, and that value we can express that value based on the term number. So here to go from 7 to 10, we added 3. Well, this term number is 2, and if I had, oops, sorry, I could express this as my n, which n is 2, so n plus 1 would give me 3. All right, so let me back up here. And if I'm expressing, so I want to find my next term, an equals an minus 1, the previous term, plus n plus 1. Okay, now I'm going to just get rid of this little bit here. And see if we can use our given sequence to see if this will work for us. Okay, so if this is my general term, or my recursion formula here, an equals an minus 1, that's the previous value, that by definition has to be in a recursion formula somewhere, and then we're going to add n plus 1. So let's try looking for the value of a3, the third term in the sequence, equals a3 minus 1 plus what is n. For each line, n will be the same. So in this case, n is 3, so 3 plus 1. a3 equals a3 minus 1 is a2, plus 3 plus 1, of course, is 4. Now we can substitute our value. What was a2? The previous value was 10, and 10 plus 4 equals 15. Okay, because we have other known values, we can go ahead and use that. So we had been given the first 4 terms. Let's try it for a5. Okay, so a5 equals a5 minus 1 plus 5 plus 1. Okay, so that means a5 equals the value for a4 plus 5 plus 1 is 6. The value for a4 we had been given is 19. 19 plus 6 equals 25. And so with this formula, we're always using n minus 1 is the previous term. I hope that helped.